Hello. We are starting with factors affecting reaction rates. And there are 5 different factors. One is nature of reactants, so the type of reactants. The second one is temperature. Temperature will change the rate of reaction, a hotter temperature, a faster reaction. A catalyst is the third one. The fourth one is the reaction concentration. And the last one is surface area. And we're going to demonstrate, we're going to do an experiment to look at each one of these factors. So part A, we're looking at the nature of the reactants. And we're going to use different acids. So I have 4 test tubes set up, and we're going to test each of the acids with the same metal, magnesium. And so I'm going to put in some acid in each one of these test tubes. And I'm going to grab the first one is sulfuric acid. And so we'll put some 3 molar sulfuric acid into the test tube, about the same height. Okay. And each one of these acids are going to have the same concentration of hydrogen ions. Since sulfuric acid has is H2SO4, I'm using 3 molar. The rest of these, phosphoric acid is 6 molar phosphoric acid. And I just put that in the wrong test tube. And I'm going to rinse that out. Here we go. We'll put this back in. So now I have phosphoric acid, if I actually read the test tubes. All right. Let's put in 6 molar HCl. And the last one we're going to use is 6 molar acetic acid. And we'll put that in the 3rd test tube. Okay. All right. Now what we're going to do is we're going to add magnesium, and you're going to look at which acid is going to react better with the magnesium. And in each one of these, I'm going to add some magnesium to it. So you can look at when magnesium reacts with an acid, it gives off hydrogen gas, and so it will bubble. So you're going to look at the various amounts of bubbles to tell which one is the one that reacts mostly with the acid. Okay, so you can decide which acid is most reactive with magnesium, which one is the least reactive by looking at the bubbles. This is, again, part A, nature of reactants, but now we're doing different metals with the same acid. So we're going to add 6 molar HCl to these 3 test tubes. So we got 6 molar HCl. We're going to add about the same amount to each one. Again, this is a very qualitative experiment because I'm not doing measurements. I'm just making sure the size of the metals and the amount of acid are approximately the same. We're just looking at reactivity. Okay. So that's 6 molar HCl. And in each one of these, I'm going to add the metals copper zinc, and magnesium. And I've already shined them up, so they're ready to go. So I'm going to put copper in the first, this test tube here. And again, all the metals, if they react with the acid, they should form some bubbles. And again, you're going to look at the formation of bubbles to see which metal is most reactive and which one is least reactive. And one question I always like to ask you students is, where do you find copper in your home? All right. All right, so we're looking at factors affecting reaction rates, and we're looking at temperature of the reaction, and we're going to look at a reaction between potassium permanganate and sulfuric acid, which is in sulfuric acid, and oxalic acid. So our two reactants are potassium permanganate and oxalic acid. And we're going to look at these at different temperatures. So temperature affects reaction rates. Usually when it's hotter, it goes faster because you're looking at collisions. And a chemist's rule of thumb, and again, it's only a rule of thumb, that every time you increase the temperature by 10 degrees, you double the rate of reaction. So that's what we're going to look at. So we'll have 3 sets of test tubes, and we're going to do 3 different temperatures. One at room temperature, one at around 40, we'll actually record the temperature, and one around 60. And we're going to have 3 different solutions, and we're going to pipette. So remember, we don't ever pipette out of the bottle. So I'm going to pour these into our test tube. So here I'm going to put oxalic acid, and I'll need about 15 milliliters. So if I run out, I could always pour more in there. I hate to use more than I need. I need about 3 mils of potassium permanganate. I'm actually going to, oh, this looks like a brand new one. So this is potassium permanganate, and you're going to see that it's this pretty purple solution. Okay, that's about 5 mils right there. And then we're going to have some sulfuric acid. So I need about 12 milliliters of the 3 molar sulfuric acid. And I'm going to put that into my test tube here. And I've labeled all my test tubes so I know what's in which test tube. 12. It's about halfway. Okay. Those test tubes hold about 25 milliliters. Okay. And so we're going to pipette out of these test tubes into our 3 sets. So in the first, out of the 2 test tubes, the first one we're going to put in 1 milliliter of potassium permanganate and 4 milliliters of sulfuric acid. And then we'll put the 5 milliliters of oxalate in the other test tube. So let's get this going. I'm going to put 1 milliliter. And it's just slow going. But when you pipette, remember you put your pipette into the solution, and you bring the meniscus to the top of the meniscus, the bottom of the meniscus to the top of the line. I'm getting a lot of bubbles here. That's weird. I'm going to put that out again. All right, I'll put that in the first test tube. Okay. I'm using 4 milliliters milliliter volumetric pipette to pipette 3 molar sulfuric acid. There's a lag time. And I'm going to put it in the same test tube as the potassium permanganate. Now the potassium permanganate, I did use another pipette, and I did repipette all those, so there's 1 ml each. And these pipettes are accurate to 2 decimal places. So you should be recording this at 4.00 milliliters. We used 1.00 milliliters of the potassium permanganate. So that's the first test tube in the sets. In the second one, I'm going to put the other reactant, the oxalic acid. And I'm going to use 5 milliliters of the oxalic acid. So I need a 5 milliliter pipette, so this is 5.00 milliliters. Okay. Now we got our 3 sets of test tubes ready. We have we need to use a water bath to equilibrate all of these, and we want to do them at different temperatures, and we want to be very the same with these. So I need to turn this one down a little bit. And then, so I have 3 different water baths here, and one is going to be at room temperature. One is going to be around 60 degrees, and one is going to be around 40 degrees. So I need to actually increase this one a little bit. And we have to equilibrate them for 5 minutes. So I'm going to set these into each one of these test tubes for 5 minutes. That stir bar's a little, I'm going to turn that off. There we go. They're touching the test tubes a little bit because they're on. There we go. So they're going to equilibrate for 5 minutes, and in 5 minutes we'll start this part of the experiment. So now we're equilibrated for the 5 minutes at room temperature, and this temperature, if you can read that, it's 22.5 degrees Celsius. And I'm going to pour the oxalate into my potassium permanganate solution and hit the start button. Oh gosh. So that's a very good time because I didn't start it right away. But here I agitated it, and then we're going to watch the solution. And the solution, when it reacts, will go from pink. As you notice, it's getting lighter and lighter. And then we see all the pink go away. And it's colorless, we stop. Now we're going to do the 34 temperature one. I'm going to have to reset here. And I'm going to put this a little bit closer so I can actually start the timer. So this is reading 34.1 degrees Celsius. And we're going to start and add. I'm going to agitate it and put it back in the solution. All right, and then the last one, this is the one at the warmest temperature. This is at 63.9 degrees Celsius. And this one we're going to be very careful and watch it as I add. And stop. As you can see, as the temperature increases by 10 degrees, it's going to, the reaction rate doubles. So one of the other factors that we can use, we're looking at factors that affect reaction rates, is presence of a catalyst. Now a catalyst takes and reduces what we call the activation barrier. When you reduce the activation barrier, you don't need as much energy to get the reaction to go. So we're just using hydrogen peroxide. Hydrogen peroxide is what you might find in your medicine cabinet at home. So we're going to measure out 2 milliliters. Okay, so that's the hydrogen peroxide. We're going to put this in our test tube. And then we're going to add a catalyst, and the catalyst we're going to use is manganese dioxide. That's the common name. The more formal name for this, for IUPAC system, is called manganese 4 oxide. And you can see it's this pretty solid. And all I need is a little bit of this, and we're going to concentrate on here to see what happens. So when hydrogen peroxide has a shelf life, and it will spontaneously, on its own, decompose into water and oxygen gas. But it takes a while, especially at room temperature. And this is cold because we store it in the fridge. So I'm just going to take a little bit of manganese dioxide, and I'm going to put it into our test tube. Shake it up a bit. And look to see if we're forming, again, oxygen gas. So it should bubble. Do you see the bubbles? So now, without even heating it up or anything, the catalyst is making that reaction spontaneously decompose much faster. If you wanted to go real fast, I could put more in, but the catalyst doesn't get used up in the reaction, so while it's there, it will continue to react. We're looking at the concentration of reactants. So we have 5 milliliters of 1 molar HCl, 3 molar HCl, 4 molar HCl, and 6 molar HCl. And we're also going to look at the mass of the magnesium. We have 4 different masses here, and we're going to put these into various test tubes, and so we know which one is in which. So to keep that straight, we're going to look at, and we're going to time our reactions, okay? And so when we time our reactions, we got to set our test tube up. So first of all, we're going to look at 1 molar magnesium. And for this particular experiment, we need to watch and time our magnesium. Once I put the magnesium in there, we're going to time the experiment until all the magnesium has dissolved. Okay? So are we ready? So in the 1 molar HCl, I'm putting the 0.0205 grams of magnesium. It's forming some nice bubbles. Probably didn't put the label high enough up there. But you can see it tossing and turning around. So it's giving off hydrogen gas. And if I had a match, I could probably light it at the top of the test tube and watch it bark. I'm going to agitate it just a little bit. Make someone try to. All right. Looks like it's all gone. All right. So now we're going to do the second experiment. We're going to look at 3 molar HCl. Make sure that's in there. And for the 3 molar, we're going to put in 0.0204 grams. And I need to reset this. And ready, start. That's the last of the bubbles. Now we're going to put in the 4 molar. And the 4 molar, we're going to use the 0.0174 grams. Ooh. Start. That was the last of the bubbles. And the last one is 6 molar. Now I have that one, it's probably too high up. And we're going to put in the 0.0213 gram magnesium. And I'm ready to start. Those bubbles are forming much faster. And the last of the bubbles gone away, and that was. The last part is a demo. And that's the last one that affects the kinetic energy or kinetics of a reaction, how fast a reaction goes, and that is surface area. And so we're going to start our Bunsen burner. Get some gas in there. A little noisy. You don't need, okay. So the first thing I'm going to do is that we have some what we call lycopodium powder. And a lycopodium powder is an organic, and it will burn in a flame. And so I'm going to show you on a scupola. I'm going to put this in the fire, and you can see it burns. But it's only the surface that is exposed to the flame that will actually burn. Okay? So it does burn, but it's a nice slow burn. And I can't blow it out right now. So we're just going to let it burn out. And then the other thing I'm going to do is put some in a funnel and take it and put a nice fine mist into the flame. And now you can see what happens when you have lots of surface exposed to a flame. That wasn't very spectacular. Let's see if this will work too. You could also do it with just this. I like it better in the flame. I'll try the funnel one more time.